Hello and welcome to today's Fire Engineering webcast. Today's event, Saving Lives with Gas Detection on the Fireground, is going to be presented by Jason Cruzen, who's a Special Operations Battalion Chief with the Columbia Fire Department, South Carolina, and President of the Fire Smoke Coalition. Today's event is sponsored by Ray Systems. This presentation is both live and interactive, so you can ask questions at any time by clicking on the Ask a Question button in the presentation window. If you're running pop-up blocking software, you'll need to disable it to view the webcast. In addition, it's recommended that you close down all other applications for better performance. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to all registrants with a link to the archive. It will also be accessible from the homepage at fireengineering.com. In addition to supporting audiences on the internet using Adobe Flash and Microsoft Windows Media, Penwell now offers webcast viewing via Apple tablets and phones running iOS. So you'll be able to watch these on your mobile devices. I'd just like to remind everybody to stick around towards the end of the broadcast because we're going to have some exit questions. And any technical questions that you may have won't be answered in real time, but representatives will get back to you on them. And now it gives me great pleasure to introduce Jason Cruzen. Jason.
Thank you, Peter. Thank you very much. Thanks for having me on. Appreciate Fire Engineering and all the attention that they're giving to this topic that I think is definitely an important one. And I'd also like to thank Ray Systems for sponsoring the event. They offer some great products, and let's get started. I've done this probably a little over a year ago, and like keeping the information on the forefront and a hot topic for everybody out there. And as part of the Fire Smoke Coalition, we collect a lot of information. I like to think of it as the focal point to be able to collect this information or disseminate and help anybody out there. Great organization. Definitely encourage everyone to check us out at firesmoke.org. So, and we'll talk more about it as we get into the presentation and towards the end. But the topic of atmospheric monitoring at fires or on the fireground is definitely an important one, and getting more recognition. It's a lot of stuff we're going to discuss today is things that we can implement today. So for those that are on duty today, when you're done with this presentation, you can turn around and start implementing some of this stuff on your own at the company level or the individual level. But by all means, hopefully spread the word and get your department in gear and start doing some stuff, because it's really about your safety, the responder, and then the community that we're protecting. So it's valuable information. The problem that we have, the solution is air monitoring, obviously, or one of the solutions, I should say. One of the problems that we have is we're seeing an increased number of firefighter illnesses, injuries, and deaths, and we have to try and figure out how we can fix this. We see the line of duty death reports, the near misses, great information, but if we don't learn from it, then we're just trying to repeat history and not improve on it. So we have a great resource within the United States on being able to track and monitor all of this information that's coming in. Well, granted, we have to filter some of it, but we get just inundated with this information every day, every hour, and we would be foolish not to take that in and be able to capitalize on it and try and improve our well-being. So in looking at these statistics, we see so many firefighters going to the hospital. We just had an unfortunate event up in New Jersey with the smoke explosion, the great YouTube, great training. I've seen numerous departments that are in my area sending this out as a training tool, and it's great stuff. And you see firefighters going out and doing their job and putting their lives in harm's way, and then you see they go to the hospital with smoke inhalation, and we see this all the time. We see firefighters getting injured, and if we can prevent that, then all the better. So we know that there is a problem, and what's causing this problem are the toxicants within the smoke. It's not the heat, the thermal issue that we're having issues with. It's the smoke inhalation part. And when we have these issues, we have to look at what's in the smoke. What's the problem? So if the smoke is an issue, then let's start looking at it, and better yet, how to prevent these exposures. So wearing our PPE or not wearing our PPE is where we're going wrong. The fully encapsulating, putting everything on, having the helmet on, the flash hood, the gloves. I mean, every little piece is going to help. And most importantly, that SCBA is protecting that respiratory, preventing those products from getting in is definitely the way we want to go. But we know we're not doing that because we're seeing the firefighters with those respiratory issues, with the cancers, and with the long-term illnesses. Because when you look at the number of fires, actual fires that we're running these days, there's not many, if any, fire department out there that's running the fires that they did 10 years ago. Fires are down. Fire or emergency calls may be on the rise because we've added in so many things, mainly the medical aspect of the job. So while our incidents are going up, the number of fires are going down or trending down, and we're seeing an increased number of firefighters that become injured or have long-term illnesses. We're seeing a lot more firefighters post-retirement or no longer running calls for the volunteers that are out there. It's not just about the paid guy that retires. It's about the volunteer that hangs the boots up and says, you know what, I'm getting old, my knees or my back or my time commitment or my physical health, and they still stay involved around the fire department. But the active firefighter that's running into the building, we're seeing them with a lot more injuries or illnesses after they hang up the boots. And we're finding that it's not the heat issue that's doing this to them, it's the exposure to all these toxicants or even the re-exposure. So that's where we need to start looking at them. And one of those aspects, which I'm going to discuss today, is monitoring on the fire ground. That's a prevention part, is if we can prevent the stuff from getting in. But there's other measures that we can do. Air management is going to help us out because it's going to ensure that we're not just wearing the air pack, the SCBA, but wearing it properly and understanding how to use it and the correct way, and not just breathing it until the bell goes off and get out. Understanding that there's safe ways to do this. Hygiene issues, personal hygiene, making sure that we take showers after we leave a fire. Once we get back to the scene or back to the station, we're cleaning up. Just simple stuff, taking a shower, washing your hands before you grab food or drink at rehab. Making sure your gear is clean. Not every department has the ability to have 2 sets of gear, but if you have it, you got a second set of gear. Move over and move that second set over and start using it while the other set gets cleaned. Or at the end of your shift, make sure that gear, if you only have 1 set, gets washed up and it gets cleaned up. So there's other things that we can do as far as prevention from getting these illnesses down the road. So with knowing that the toxicants are an issue, then I really like diving into the air monitoring side of it, because it's something that we can look for and help us identify what's out there, and better yet, when whatever it is out there is gone and it's safe for us to go ahead and come off air. So a picture I like to use here is, as an example, is would you enter this space without an SCBA? We have jumping around here. A 1 ton there, a little zoom in for you, a 1-ton chlorine cylinder leaking on a loading dock. And hopefully nobody would answer that question with, sure, why not? Just chlorine, right? It's a hazmat scene, and we as responders look at it as taboo, or the call that nobody wants to go to, the hazmat call, unless you're that hazmat technician that's out there. For the general first responder, the fire guy, the guy on the engine, the guy on the ladder rescue, that's something that's unfamiliar, uncharted grounds. It's not a normal call that we're accustomed to seeing. So when we see something like that, we're concerned. We're fearful. We've been taught and drilled from day one, rookie school, with hazmat awareness, that this is bad stuff and you don't want to go in there. So people are going to be apprehensive. Even with the proper PPE, people are probably going to tend to be a little leery of making an entry in that area. But when they do, they're going to make sure that, you know, every zipper's zipped and every flap is closed and taped and double taped and secure, and there's a plan to get people out if something happens. I mean, there's so many things that go into the process because it's a hazmat scene. But when we pull up on the scene, we're going to go to work, but in a safe manner. And we're going to start looking at things like wind direction. Where is this product going? What is the product? Where am I going to be as a responder in a safe position to be able to work from that initial setup standpoint to make sure I'm in that appropriate area. So it's all about safety, safety, safety. We're never thinking, or typically not thinking, about the mitigation side of it. So nobody's wondering, well, where's the leak coming from? What can I do to fix it? That's down the road once we've identified the product and done everything that we should be doing on the hazmat scene. So some of the ideas that I've started coming up with was, if we're not going to enter this area because it's an IDLH and it's a chemical issue, a hazmat call, then realistically, why are we doing it here? We go to a structure fire, it's an IDLH, you could pretty much make sense that it's going to be or a hazmat type call. Granted, there's a fire, that's our primary response, but when you start to look at what's there, not much different or possibly even worse than the green cloud from the previous slide. We're dealing with chlorine and chlorine only there, and when we come over here at the structure fire, we have that toxic soup. We can generalize what's in there, the carbon monoxide and hydrogen cyanide, the aldehydes and oxides of nitrogen, and a plethora, just a unknown amount of toxics that are floating around, not only just in the smoke, but in the area. And that's really where we're going to jump into a little bit, because so many times firefighters think, well, I'm not in the smoke, or I'm not in the building, so therefore it's safe. But when we start to incorporate some of the meters into the fire ground, and we start to look at where the true danger is, it really starts to open up your eyes, and it allows you to see, that tool allows you to see things that you can't. No different than a thermal imager in a fire, obscured vision, but it allows you to kind of see through that and look at things that are not visible to you, or on the same line of a smoke detector. It allows, an alerting stance to where maybe we may not be in a position to see that, where we're sleeping, resting, and we're out of it. It's there. So it's a safety mechanism, it's a tool, a technology that's around, and quite frankly, a lot of us are using that. So that kind of gets me into our first survey question, and trying to look at who out there is doing that. So I'd like to send this survey out and see, take a moment to jot down there and answer this poll and see what we can capture, and see who actually is doing some type of monitoring on the fire ground. So because when we pull up on a scene like this and we see this, it's comfortable to us. We not so much complacent, but we're used to seeing this. This is an everyday or an every week or maybe a once a month occurrence for the firefighter. When they pull up, they see this, obviously there's something burning inside, whereas that hazmat scene, that may be a once a 5-year or once in a career type run, those major hazmat incidents. So rightfully so, it's not a high frequency call, so we're apprehensive, but we still owe it to ourselves to have the same level of respect for our body, and we owe it to ourselves to protect that, or our fellow firefighters, the personnel you may see. You may be a safety conscientious person and realizing that you have to take care of your body, and you can help your fellow firefighters out and kind of give them a heads up or call them to the side and say, hey, we need to mask up now, or let's step back until we're ready to make an entry. So we can help each other out. So we go to these fires, and we may run into a call that's not the typical fire. We go here to a university or a high school or somewhere where there's a laboratory setting. When we get that call and we're responding, we get report of smoke in a building or a structure fire reported. Once we find out that it's a laboratory, we're probably all going to slow down just a little bit and find out maybe what they have in that area. Was there anything going on? What was the cause? Is it just somewhere in a room next to it, or is it in a room? There's going to be a lot of questions to be asked before we commit our crews inside. But not that we're not going to do it, but we're going to make sure that we protect ourselves. So we see the firefighter over here, and this is several years ago, probably about or before the time that we were actually doing monitoring within my department, but yet we have a firefighter that is wearing a multi-gas meter strapped to his PPE, and as you see, no smoke conditions in doing overhaul or surveying the area, but because it was that potential hazmat, then metering came into play. And a lot of times firefighters are so quick to come out of their PPE. We're fortunate because we have industry that's out there, manufacturing this PPE that's making it lighter and more agile and more comfortable for us to use. Now, granted, it does have some weight, but we're fortunate to have that stuff, so it's not so terribly as it was 15, 20 years ago when we were looking at solid aluminum or even steel cylinders, when it was that cumbersome, heavy weight on your back. So not any firefighter at this scene was quick to come out of SCBA, because they had that concern and that little wheel spinning in the back of their mind that says, wait a second, this is a lab. And while the fire wasn't very big, there was damage and there could have been chemicals released, and it wasn't. There was controlled, and as you saw by the picture, it wasn't a very big fire, but still, because it was that laboratory setting, everybody was concerned and afraid that I don't want to breathe something in because there might be something bad out there. So if we take that same stance on the regular structure fire, residential type structure, that's our bread and butter call that we typically see, that we are complacent in, that we say, well, it's just smoke, it's just a residence, what's the issue? The smoke itself is bad, but who knows if it was somebody storing something in their house or some type of clandestine or illicit lab that was in there, and there were chemicals in there, or it was a residence that was converted to a doctor's office and they had gases in there, or some type of commercial building. So we don't know, and we only see the outside of the building, or if we have a pre-plan and we're fortunate enough, we see that. But there's so many things out there that we have to be concerned of before we just blindly remove our air and start walking around. So having metering on the fire ground is going to provide another level of protection. Is it the answer? No. I mean, there's many gases out there, but we can look for some of the hot gases that we're going to see, or hot topic gas, I should say, not hot, but are more prevalent, and ones that we can fix somebody if they're exposed to. So while we tend to, the coalition, and while I tend to emphasize carbon monoxide and hydrogen cyanide, is because we can fix somebody, we can assist them if they're exposed to those two products, and they're very prevalent at fires, going out and looking at. Medical testing has shown, firefighters being exposed to both of those, or just smoke inhalation patients for that. So if we know it's there and we have ways to correct any wrongdoing of that product being in our body, then why not look for it? But on that same line, there's many others out there. So I definitely encourage you to branch out and look for other gases as well if possible. But we'd probably have to have the meter size of a vehicle if we were looking at every single known gas, and the companies would have to have a very large cache of sensors and cow gas. So from a realistic standpoint, we tend to look at the CO and HCN as the two typical. So when we look at the anatomy, I guess, of smoke or the fire, we have that product that we see, the smoke, the carbon, the soot, that big product, the stuff that we see. That is the identifying marker for the firefighter, but we think as fire, the flame, as being bad, and the smoke as being just smoke. It's a byproduct of what we're going after. We're taught, don't put water on the smoke. The smoke's just there. Go to the fire. So we're always educated from day one on what the culprit is, and the culprit is the fire. The smoke doesn't burn down the house, it's the fire. So we're going after the fire, and the smoke is just that necessary evil that comes along with the fire. So when we see that and we say, well, we're not in the smoke, or it's just smoke, it's not really the smoke. Now granted, smoke itself, the particulate, the soot is a carcinogen, and it is bad, but there's so many other things that kind of go along with the smoke, the gases that are out there, hundreds of gases that are there that we can't see. Guilty by association by hanging out with the smoke, but also not afraid to get out on its own and do its own thing. And when you start metering and you look at these gases that you can't see, that you're not going to be able to identify on the fire ground with the naked eye, we're going to quickly realize, or you, once you start metering, that when you bring these meters out on the fire ground, realize that where you typically stand, or maybe standing at that point in time, may not actually be safe and not be in the smoke. It's not unrealistic to be standing 10, 15, 20 feet away from a structure, not in the smoke, but yet getting readings, significant readings on a meter, because those gases are escaping, they're pushing out, they're pressurized, but they're lighter than air, they're going to move more freely. So when that thermal issue comes in and it starts moving these gases around up and out, those are probably going to tend to travel farther and maybe not be where you see the smoke, but where you can't see the smoke. So we have to really look at, we have smoke, which we can see, but then we have the fire gases, which are going to far or exceed the perimeter of the visual that we have. So it's important that we have something to be able to see that, because we can't, and that's where metering comes into play. So we see a typical single-family residential little bungalow-style home. Definitely a well-involved fire. We see a firefighter masking up, upwind, maybe a little too close, but we're getting better. But we come around the front side and we see some firefighters, the typical setting, masking up at the front door, and most likely I'm willing to bet there was a nozzle somewhere under someone's knee out of those two gentlemen. So it's not anything that we haven't probably all seen or done on the fire ground. And the bad thing about it is we train our firefighters to do this. We train the firefighter to wait to the last minute to save the air, tie it back to that safety issue, to say, you know what, you might need that air, so let's not waste it. Let's not breathe it out in the front yard. And I'm sure there's probably 10 T-shirts you can buy about firefighters breathing air in the front yard and the bad thing that it is. But when we start looking at it, it's not really that bad of a thing, and it's not really that wasteful, because we tell the firefighter, wait to the last minute, go to the front door, drop to a knee or mask up there before you go in, and you are saving 3 to 4 breaths. And those are 3 or 4 breaths you might need in the end, or if something goes wrong, you might need them. But when we really start to look at it, the firefighters that go down in the fire, or the firefighter that gets disoriented or puts himself in a position where they can't get out, or there's a malfunction in the PPE, or poor planning, whatever it is, conditions change and they didn't plan on it, but guess what? They're in an area they can't get out right away, and now they're going to need a lot more than 3 or 4 breaths. When you look at the line of duty deaths or close calls, and you look at incidents where firefighters have had issues, it's not 3 or 4 breaths. It's 20 or 30 minutes that it's taken somebody to either recognize they're missing, locate them where they're found, or them to get out on their own. Very seldom is it a 3 or 4 breath issue. And if it is a 3 or 4 breath issue, then we are going wrong from the training aspect and from a department aspect to educate the firefighters on the importance of air management and making sure that we know ahead of time what our limits are. And because we know that's an issue, NFPA is changing those standards for us and saying, hey, you know what, we're going to help you out, firefighter. We're going to adjust those settings, and we're going to now make it a third instead of a quarter when that alarm starts to go off. So, you know, I've heard firefighters complain that we're losing working time. They're tying our hands. You know, we can't do any work anymore. But it's for the interest of safety. And if we're talking safety, then let's talk safety and put ourselves, because we're not working in a safe atmosphere. We're waiting to get up, as these firefighters are here, and it's been done every day. I'm guilty of it, waiting to the last minute, because that's what we're educated on, to save our air. And it sounds good, but when you really start to look at it, it's not really good, because we're sacrificing 3 or 4 breaths, bad breaths. So while these firefighters are getting dressed, they're taking in those toxic gases, and they're putting themselves in an unsafe area where if something goes wrong and somebody's on the backside and they open up, or somebody takes a window, or the fire self-ventilates, and something happens, if that front door is open, it's going to follow that path of least resistance, and now they're going to be enveloped in superheated gases, fire, and because they're not dressed, now they're running into issues. And we've seen firefighters in that same position either perish or become severely burned because they put themselves in a position where they're not in that safe area, or they're not completely wrapped up, and now they're exposed and they get burned. So definitely important, because 3 or 4 breaths, if that, and that's about how long you're going to be down on a knee getting dressed. If you say, well, if I'm using 3 or 4 breaths and I'm taking that bad stuff in, let me take 3 or 4 breaths of air of that SCBA and maybe get dressed or mask up, actually go on air, maybe out in the yard by the mailbox or a distance away that's safe, go on air, approach the building in that safe area, because if that was a leaking chlorine cylinder like we had in that first slide in the beginning, the guy going in a level A suit would never think about saying, well, I don't want to waste air making my entry. I'll just wait until I get 30 feet or 100 feet away, and then I'll go on air and zip up the level A the rest of the way. No, they're probably going to want to add 10 feet on the safer side and say, you know what, zip me up now, and I'll just go on air, and I'll calculate that into my usable work time, because I want to make sure that I'm safe. But when we go to the fires, we don't think that way. It's rush, rush, rush. I got to get in. I got to be the first one in. I got to have the nozzle, or I got to be the one to do the search. And it's with good intentions to be able to be the one to put the fire out or make the save, but we're so often sacrificing our own personal well-being in doing that. And we just have to slow down just a little bit and be able to better protect ourselves. So we go to fires, and we pull up and we see smoke coming from it, whether it's residential or commercial. We're making plans to go in and combat the fire, because if we treated it like a hazmat scene, which I wish everybody would start to do a little bit, if we fully did it as a hazmat scene, we're probably going to burn down some buildings. Because by the time we set up all the stuff we need to set up and get our 3 points of reference and weather and all the other things that we typically do on a hazmat scene, that fire is just going to keep progressing. So but we can do some of the things, and we can use some of the things that we do on the hazmat scene and incorporate them into the fire ground. Definitely adding to that safety component and making sure we take care of ourselves. And one thing is that of the NFPA 704 marking. We have a commercial structure and we have gases in there or chemicals. We have something that's bad. The building code says, hey, building owner, occupant, you need to properly identify that building. So if responders come in, they're aware that there are dangers and what type of dangers there may be. So if we take that and we say, well, we know there's smoke, right? We see the smoke, and we know there's going to be those products of combustion, those toxicants that are hanging out with the smoke and being produced as part of the combustion process. If we know all that bad stuff there, maybe we need to reinforce that hazmat side and get everybody thinking. So we could most likely just take a nice NFPA 704 and label it, laminate or laminate it, put it in the front seat of the truck, and then when that first in unit gets out and does their 360, they go ahead and they just slap one up on the building. Because hopefully every truck that comes in after them is going to stop and question and make sure that somebody has identified that and is aware of it. And that's typically how it happens. You pull up at a commercial building and somebody's walking around and they see that building, that label on the building. There's usually questions raised and followed with a request for a pre-plan or some type of MSD as a representative, and most likely the hazmat team is going to be rolling out on it. Because somebody's going to want to know very soon what's going on inside that building that they need to be concerned about. So if we take that mindset, that hazmat mindset, and start to bring it into the fire scene, we're going to be safer, and we're going to see not just the line of duty deaths, but those illnesses, the long-term stuff that we see, or the delayed onset, the injuries and the complications that we as firefighters are seeing more and more every day, every year. We're going to start to see hopefully that stuff kind of reverse itself, and we're not going to have firefighters running around with unfortunate conditions after they retire or later on into the career. So how we got started in Columbia was by accident. We went ahead and looked for a meter. We had some meters that were in need of repair, and we couldn't get parts for them. It was an older meter, and we had to try one out. So when we got it, it just happened to be an HCN meter. By accident, we wanted a CO, and the sales rep said, well, I've got this meter. This is the meter you would get. I don't have a CO, but you know what? Try it out. Let me know what you think. And if you want to see a CO, I can bring one by. But play with it. The menu's the same, and the actual frame and use is identical. So we said, not a problem. Took it, played with it, turned it on, went through the menus, looked how to calibrate it, the typical stuff that the hazmat guy is going to want to know with a meter. But the inquisitive firefighter in us kicked in, and we saw that HCN and really didn't have any existing idea of why that an HCN meter would need to exist. So we get on the trusty computer and start doing some searching, and of course we found that the typical stuff that we expected, that there was chemicals and what type of industries use cyanide. Why would we need why would there be a need for a hydrogen cyanide meter? But we weren't expecting to find some stuff on fires, and that's what really kicked it off for us, was seeing that there was a report from Providence, Rhode Island, from about a year prior to, where some firefighters were injured at a fire, being exposed to smoke. They had I guess a near miss, a firefighter go down, and the chief had the wherewithal, or the members of the department said, we need to investigate this, and then more importantly, after investigating it, is we need to kind of publish this and make it accessible to the response firefighting community, to where we can learn from this, and hopefully others can learn from it. So that was an eye-opener for us, and that report is definitely a good read, and I guess probably one of the first, or the big events that really launched this. A lot of people look at that as a significant event that really opened the world of smoke up to the responders. And then there were some publications that the coalition, the Fire Smoke Coalition, had put out that were all educational about smoke, air management, and the health effects of cyanide, and how to better protect ourselves. So we read that, and we created a brief summary to present to the chief, and said basically, we want to go out and we want to look for this. We want to see if this is a problem, and it intrigued us. So we used the meter that we had as a loaner. The vendor, we called him up and said we want to try something out, and of course he was intrigued as well on what we found. So we had a little while to play with a meter, and we went ahead and began going to fires, or wanted to start going to fires, and we did. So first fire we go to, next shift or so, and pull up and pull the meters out and run through, and we knew CO was there. And we had some single gas CO meters that we were kind of using at fires on an overhaul type situation. We didn't use them at every fire, but they did get some use, and people were aware that CO was a culprit on the fire, a byproduct there that we had to be concerned about. But sometimes we didn't necessarily do what we were supposed to be doing. But we pulled up on the scene, and we had this new meter out, and we go in, and sure enough, we got readings of hydrogen cyanide. And we quickly realized that hydrogen cyanide had arrived in Columbia, South Carolina, that it was there. It wasn't Providence. It wasn't California or Mexico or England. It was here, and it was in Columbia, and it was affecting us, and it really opened our eyes. So we said, we have to go out and we have to see how much of this stuff is out there, where it's at, when is it there at the fire? Is it just in the beginning? Is it, during active firefighting? Does it go away right away, or does it hang out, or is it more prevalent during the overhaul process? So we really wanted to go out and try and get as much information as we could on these fires. Two significant fires that were really making things or putting them into perspective, because we caught the first couple and they were a room and content fire, or a good working fire, and we expected to find that stuff there. But one of the early on fires that we went to, we were second in, and a second engine in. An engine and a ladder were pulling up on scene. As they were pulling up on scene for a report of a kitchen fire, the dispatcher radios back and says, we got a report that the fire's out. So automatically the firefighters are dropping their packs. Typical pot on the stove, or burnt popcorn type thing. We see this all the time. It's just a little bit of smoke. The officer confirms very light wispy smoke coming from the building. They were just going to do smoke removal. So we had our meters. We hadn't really been to this type of call, or this minor type incident. In our eyes, was a minor type incident at the time, until we got up to the front door and made entry and realized that it wasn't so minor anymore. Getting such a high level, and you can see by the picture on the left, the kitchen is that green room in the back with the door propped open, and you see the extent of the smoke damage after the fire. Very, very little damage. The picture on the right is where the stove was, underneath that cabinet, open face cabinet. I had the typical kitchen items, the spices and salt, pepper stuff that was in the little plastic bottles up on the shelf. Probably a couple plates and some appliances on the counter next to it. Nothing out of the ordinary from a typical kitchen. But when we get in and we see these numbers and the very small amount of smoke in comparison to the readings we were getting and what we had received reading-wise from previous fires, that this was probably one of the highest at that time that we had actually seen these meters go. And it was, at first we thought maybe there's something wrong with the meter. What are we doing? But we were able to get a couple of meters, different manufacturers, that we tried out in this process to be able to see what we had and what meter we liked, and to try them out. So of course we want to know if that meter is working correctly. So one of the guys comes over with his meter and stands right next to the other guy, and sure enough, it confirms the reading. We walk around and quickly realized what was causing the problem. And when we see these smaller fires, the little kitchen fire, pot on the stove type thing, we're heating up the Mr. Coffee, the coffee maker next to it, the microwave oven, the cabinetry, the paint, or maybe like the spice jars, the pot handle, the pot, the enamels on the stove. We're heating these things up. We may not have that big rip-roaring kitchen fire. It could just be a simple fire contained to the pot, but it heats up all these products around us, the countertop, the glues, the laminates, everything that's around that area, and it's releasing those gases. As soon as we start to heat these things up, some of these things, some of the plastics, you know, a couple hundred degrees, 300, 400, 500 degrees, these things are off-gassing. And they're starting to dump out a lot of gases, and the fire that's nearby isn't that big yet, so it's not consuming that. That's not a fuel for the fire as of yet until that fire really starts to intensify. So as that fire, the radiant heat goes out in front of the actual fire, it's heating up and it's breaking down these products and releasing all these gases. And nothing's really burning, so you're not getting a lot of incomplete combustion, so you're not getting a lot of carbon and soot, but you are getting the gases. And as soon as you start to change that chemical state and you start to soften those plastics, those things are being released, and now they're filling the air. So that really opened our eyes to what we were looking at was something that we couldn't actually see. Another one that was kind of on the opposite end of the spectrum was one where we had a big fire. We had an apartment fire, a garden-style apartment. In this picture you're looking at, the Charlie side. Fire's in the Alpha Bravo corner, back in the far end. Escapes, breaks through the window, self-ventilates out the kitchen. You see the fire. The guys did a great job. Go in, get a good knock on the fire, kept it to the apartment of origin. You know, pretty good fire damage to the living and the kitchen area. Kept it confined. Obviously, you see smoke pressurized throughout. Hook some sealants, check it out, everything's fine. An hour and 45 minutes after the fire, we get a report that the occupants up close here on the Charlie Delta end want to go back into the apartments, reoccupy. All the lights are gone, the firemen are leaving, the excitement's over with, and now they want to go back in the apartment. So the chief assigns one of the ladder companies to go over and check it out. And they report back on the radio that they had a strong odor or smoke, they had some smoke, that they were going to blow it out. So we were on scene, getting ready to take up, and we hear this come over the radio. We said, well, let's go try it out. Let's just go see what we have being this far after a fire. Let's go play around. And as soon as we got probably within 5 or 6 feet of the door, that acrid odor, just the tearing of the eyes, the irritant that was within there, those irritants were really just hitting us like a brick wall. So we mask up, we go into the apartment, and it was pretty well clear throughout. We could see walking around, maybe a slight haze, if anything, more of a dust, if anything, and our meters skyrocketed. 79 parts per million of HCN and 49 of CO, an hour and 49 minutes after the fire. Because, as you see in the picture, the smoke pressurized the entire building, floor to ceiling, wall to wall, and an hour and 45 minutes after, the heavy stuff, the soot, the particulate, is now no longer heated, and it's heavier than air, and it drops like a brick. And everything had that soot, but the gases, like CO and HCN, are lighter than air. So those two gases want to kind of stay up. They're ambient, they're neutral. They're just below 1, so they're going to hang out. And when we walk in and we look at it as a typical firefighter would, and I've done in my past, said, oh, it's not bad. There's really not any smoke. We'll open a window and we'll let it air out. But to realize that those gases are still there, I mean, it was really shocking for us to realize that they hang around. And when you start looking at the hazmat side of it, the chemistry, they're lighter than air. So they're going to hang out. They're going to stay there. And with the building being closed up and not ventilated, they go in, they do a search, but the door gets pulled shut or doesn't actually get ventilated. We're leaving those gases in there. So what we did as far as the project wasn't really a scientific study, but just going out and monitoring real fires, real time, not planned, not training fires, real actual fires. We did that for about 8 months, and we captured about 40 fires that we were able to get readings off of. Sometimes we'd go to a fire and they'd already ventilate, or it wasn't nothing to it, or maybe somebody didn't remember to bring a meter, whatever it is. But we were able to get 40 fires that we were able to capture data, and in looking at it, we wanted to use that as an educational tool to show firefighters what they were putting themselves into, what type of readings we were getting, but also to look at, do we need to look at HCN? Is it an issue? Is there a need to go out and add another meter? Can we just get away with the CO? And we quickly realized that we can't. We can't do that, because when we went out and monitored at these fires, there was no correlation between CO and HCN. We'd go to some fires and there would be high levels of CO and not so high HCN, or some fires where we had higher HCN in relativeness to the CO. Typically the CO is going to be higher, but when you look at them, the correlation is just because one was high didn't mean the other one was necessarily high or even registering present. So we realized, well, we're going to have to start looking at HCN as well. HCN was far more toxic than CO, and we had kind of haphazardly going about the process of looking at CO and monitoring on a fire ground. We were doing it, every couple fires. Out of every 10 fires, we may have monitored it, maybe 2 or 3. Someone remembered to pull the CO, but it kind of hit us and said, you know what, here's HCN, and it's 24 times more toxic than CO, and we haven't really been doing a good job at CO, and now here comes HCN. So, big eye-opener. The other thing to kind of point out is it's not anything that's new. It's been around. It's been there. You can go back and look at the early editions of training manuals, and when they talk about fire behavior and products of combustion, the cyanide was there. The hydrogen cyanide is nothing new, but we're starting to learn more about it. We're starting to see through things like the report from Providence, Rhode Island, and going out and actually just trying to try some things out and do some metering on the fire ground to realize that there's other products that are out there that are just as, if not more dangerous than CO, which is the typical overhaul type gas that we're looking at. So we monitored it at all the structure fires. We monitored everywhere. We looked out at the front yard. We looked in the backyard, upwind, downwind, in the fire room, room farthest away from the fire room, in the basement or on the top floor of a multifamily to see, and just kind of see what type of readings we were getting and if there was that consistency. And as I mentioned before, there wasn't any. What we did was we had our hazmat unit respond for consistency on all 3 shifts. They had the meters. They went out and they looked at it, and our findings were amazing, and a real eye-opener, and it later on became a good teaching tool to be able to show people what type of readings, because they want to know, well, how bad is it? How bad is bad? How dangerous is hydrogen cyanide compared to CO? So, firefighters, they want to see, people in general want to see numbers, statistics, how. So it gave us a tool there to be able to try and help educate the firefighter and track that information. These were the meters we used. We used some single gas electrochemical sensors. They all worked well. We liked the fact that the ToxiRay 2 had a higher range sensor, and at that time we were really looking at how high could we get this thing to go. Being the typical fireman, let's push the envelope, let's see how high we can get it to go. But then we quickly realized we didn't need to see that. It really didn't matter a whole lot, but we liked the simplicity of the meter. It was easy to operate, and we ended up choosing that single gas, that Ray meter. But those were the 3 that we liked, but they all perform well. Can't talk about any of them, but ended up going with the ToxiRay 2. I guess the icing on the cake that we really liked about it was firefighter proof, or at least really resistant, at least in my eyes. we had a fire right there before the demo was over, and we had the meter for several months, and the vendor was coming by to pick it up, and we appreciated him loaning it to us. And as we go to the early morning fire, you see a couch there between the two windows, and that's on the Bravo walls. We're entering the Alpha wall, that Bravo wall's on our left. My firefighter alerts me that he's dropped the meter. It had a little bit of smoke in it. The fire was out. We were going in more of an overhaul, hitting some hot spots, and he drops the meter. The meter comes off as SCBA. So proceeds to look for it, couldn't find it. We ended up having to go back to the scene after the fact, and when we did, we located the meter. It was still alarming, probably an hour and a half after the fact, and just fully involved fire. Rooms were, compartmentation was non-existent, and the fire was through the roof. So most of the drywall that was there ended up on the floor along with all the water, and we located the meter just in front of the sofa there, and it was buried face down. As we uncovered it, I took a couple pictures, and it was almost completely full of water. Still alarming. We were able to hear it, a little muffled, but still alarming. Went back, cleaned it up, and we proceeded to use the meter, test it, use it side by side with other meters, and it continued to work. So that told us that what was thought to be a very technical piece of equipment can withstand some pretty amazing things, and including firemen. So we ended up buying some of these to marry up with our existing 4-gas meters that we had. I'm going to talk about some ideas or some concepts of metering in just a minute. This is a form that we used for monitoring on fires. Looking down the left at some pre-designated areas that we wanted to look at. We would record the times, go to an alternate channel, and look at or work on a opposite fireground channel, and just go in and record these readings at the fire. Pretty much once the fire was knocked down, we were inside. Before the fire was knocked down, we were outside, maybe metering downwind or out at the command post or by the trucks. That is, if we weren't involved in active fire duty. If we're in there and we're first, second, third in, then we were participating in a fire. But some fires we were able to go to that we weren't on the initial dispatch, and kind of get some things done as far as monitoring around the fireground. Again, another typical, just a little kitchen fire, but got some really high readings. Now, looking at the options, as I said, we went with a single gas unit to add to our typical 4-gas meter, and a lot of departments have those 4-gas meters or multi-gas meters. So, kind of push this next one out here. Is your department currently monitoring at fires? Is that something that you're currently doing? Definitely love to see what people are doing. As I said, stuff was really getting out there. There's more information. You see articles now in magazines and webinars like this that are getting out there, getting the subject out there, and I like to think that the Fire Smoke Coalition has a lot to do with it, but just really getting the information out there. So I'd love to see who's out there currently looking at fires and doing some type of metering. We have options that are definitely out there with having a 4-gas. A lot of people already have 4-gas meters that are available to them. Some of those are for other reasons, smell of gas, smell of gas, CO calls, just general suspicious odors maybe. So we see now with technology the way it is, the price is coming down, we will increasingly more even now, but in the last couple of years have seen these things really get down, $1,000 range, or maybe even cheaper than that for a typical multi-gas meter, is having these on the first out rigs. But the typical setting that we see these things are CO, O2, LEL, and H2S. So the reason that you will see these, and the reason or the explanation I get from most people is the H2S is there for the confined space issue. But some areas may run a lot of confined space calls, but it's not an everyday call. It's not a typical call that we see, but almost every single day in the community, or maybe the community next to you, these are calls that we're going to that have smoke, and not the confined space calls. So we're carrying around a piece of equipment that isn't quite what we need, and if we can change it a little bit. So what we started out with was the typical 4-gas, and we added a single gas HCN. And that met that need at first. And we were really in that infancy of looking at what we could do. But after thinking about it and how often we were using these meters on non-typical hazmat calls, we started starting to see them more used on the structure fire or call involving smoke versus the smell of gas or the suspicious odor call. So in doing that, instead of carrying around 2 pieces of equipment, we left our rescue companies with the H2S for that confined space issue, the concern of running those. But the rest of those companies that had the 4-gas meters, we now have switched over and got away from that single gas and added the HCN in lieu of the H2S to be able to provide us that one piece of equipment that now comes standard. There's some colorimetric technology that you could use as well. So there's a lot of options out there. So if you're looking at your department, don't think that you necessarily have to go out and buy a whole new piece of equipment. It could just be modifying what you have. Or if you're a small department or you have 2 or 3 pieces of equipment in your station and they all have a 4-gas, you leave one with the H2S, but you can pull in that HCN, and you're going to really find yourself using it more often. The other thing to think about is, when do you meter? As I said, when we were doing the study, we were out there as soon as we got on scene, and realistically, that's what you need to do. Don't need to take it into the fire, but it can be active and running on the fire ground for those personnel that are outside. RIT teams, staging personnel and staging. A company pulls up on the scene, you don't have an assignment quite yet for them, and they're out, and they're usually typically hanging in the front yard. If they hang out there for any period of time, they're not going to be breathing air, so they have the ability to start breathing in some of these toxicants. Pump operators, incident commanders, personnel that are going to be operating around the fire ground, not necessarily in the structure or up close, but still run the risk of it. So having that meter on and running, even if you just had one, keeping it out there until you're ready to go ahead and monitor the fire inside for overhaul situations. Where do we meter? Is a good question. A lot of people ask, well, where should we meter? Everywhere. Anywhere you can get to. Obviously not in the fire, because you're going to tear up some meters. You're going to saturate the sensors and just really clog them up with all the particulate. But all over the fire ground. Like I said, out at the command post, anywhere you have personnel that are staging or hanging out, definitely. Because what you're going to do is you're going to create a comfort with the unit. A firefighter that doesn't understand a piece of equipment is probably not going to pick it up to use it, because he doesn't want to show his inadequacies or his ability to operate the piece of equipment. By using a meter on every fire scene, it's going to become second nature, no different than a thermal imager or a tool or a piece of apparatus that you're going to use. The more you use it, the more proficient, the more comfortable you get to use it, and that's the plus side by having this all the time. So what should our fire ground look like? Basically, personnel walking around in SCBA. If we're operating, and people will say, well, I'm not in the fire. Well, your life outside the fire is no less important than the firefighter on the nozzle or pulling ceilings or opening up on the roof, whatever it may be. Anybody operating within that scene, their life is important not only to them but to the department. And we have to protect that, and making sure that we protect ourselves out there. And it may be, well, I'm going to use part of my cylinder performing tasks, but those are necessary tasks. So whether your task is on the nozzle or pulling a ceiling or securing utilities, they're all important tasks, and it shouldn't be that one requires PPE and the other doesn't. So when we say you have to be in full PPE, that means wearing the mask and breathing the air. So we definitely want to make sure. The other thing that I like to think about is when we're operating on this fire ground is making sure that we operate in a safe area. And on the hazmat scene, we have control zones. So we have a cold zone, the warm zone, and a hot zone. Very, very simple. And some firefighters are apprehensive of using hazmat on the fire ground, but we already do it and we don't even realize it. We set up a collapse zone. Typically, not common on it's not as common or common at all on a residential, but we can incorporate it. We can use that same mindset and say, okay, our initial hot zone right off the bat is our collapse zone. So 1.5 times the height of that building is your hot zone. So if you're in that area, you need to be cognizant that you're in a danger zone and you need to be masked up and breathing air. That it's important. So that's a real quick down and dirty on your initial isolation zone. Obviously a bigger fire or looking at wind direction and setting up downrange metering. I mean, you can really go out, but that's a good starting point. The other thing is when is it safe? We as firefighters become goal or task oriented, and the Pavlov's dog really rings true in this aspect. When the radio keys up on the fire ground and a firefighter reports he has a knock on the fire or recommends the fire under control, that's the indicator that it's time to come off air, that the fire's out and it's safe. When in all actuality, that is probably the absolute worst time that you could come off air, is you've just extinguished the fire, nothing's left to consume that energy, all those gases that are there, and now they're hanging out and they're at their peak as far as the quantity, and that's the point in time that we feel we need to take off our mask. So we need to make sure that we don't take our mask off just because the task was complete or we've got a knock on a fire, that we've actually identified that atmosphere and said, hey, it's safe, it looks safe, and now I'm going to confirm it and I'm going to do some type of metering. Staging and RIT, I've talked about that. The crews that are operating as a rapid intervention or just awaiting an assignment on the scene will tend to congregate very close in an attempt to alert the incident commander that they're available, they're ready to go, and they want to get inside. So we're going to see those personnel gravitate towards the structure close to it and end up inadvertently putting themselves in harm's way. So making sure we stage in a safe location. Incident command tends to get the tunnel visions from time to time, and we might find a chief officer operating a little too close. So having that meter is a good backup, a good dose of reality. So getting too close, operating, we all as incident commanders want to be able to get a good 360 and look at the building and make sure that we've assessed the structure, and we should, but we don't need to jeopardize our own well-being and make sure that we take care of ourselves and protect ourselves. So having a meter on the IC is a good way to save them. Overhaul, we're all guilty. This is probably the most prevalent time that we're seen to be operating without air. Most of the time with the air pack still on, so it's not even we're doing it to save the weight. We just drop the mask, and the cylinders are still plenty of air in there, and we're inside doing overhaul, salvage type operations, and we're walking around in this stuff. Very dangerous. If nothing else, all the particulate matter, the soot that's there, and we've all had the snot rockets after the fire, and a couple hours after, the next morning you wake up, take a shower, and that's the bad stuff. That's the stuff that was filtered. There's so many other things that get by that got into the lungs that affected us, and we're not even realizing that. So that's a scary part. Our fire investigators, an unprotected resource. Typically, they're going to show up. They might have some boots on, some gloves, and maybe a hard hat or a helmet, and they're sifting through the ashes or down on their hands and knees or digging through this stuff for an extended period of time. And while it's not during the fire, it's a dangerous side of it, and we need to make sure that we protect them or they get protected, because even though it's an hour after the fire, we saw from an early on fire, we still have those gases that are trapped in there. We still have heated materials that are going to continue to off-gas, and now they're down on their hands and knees and they're sifting through it. So making sure that either they have the protection or the monitoring to know that this stuff is no longer there. Really been hitting structure fires, but it's not just the structure fire. It's the dumpster, car fire, even wildland fires. Protecting ourselves, not necessarily wearing the air pack, but how we approach the brush fire, where we stand, how long our work cycles are, what are we doing, are there preventive measures that we're not doing. The stopping wet bandana is probably not the best tool for respiratory protection. I'm not a big wildfire person, but I'm sure there's plenty of others out there that can offer better insight. Car fires and dumpster fires are nasty things. You want to see a meter get maxed out, you take it to a car fire or dumpster fire, and you'll quickly see the meter max out, go out of range, and this is just, they're nasty fires. There's nothing natural about them. They're all synthetics and plastics, and it's just a big chemical toxic soup that's there. This picture here was a dumpster fire we had, not standing in the smoke. The meter was at front bumper of the truck about 25, 30 feet away. Wind blowing from left to right, and you see the readings, and we actually got up to 25 parts per million in that location. Alarming numbers, thinking about, bystanders, who's standing around, who's watching, the public, so making sure that we also ourselves are packed up and putting ourselves in a safe location. Car fires, we know those are nasty and dangerous. Don't see as much problem with the car fire, but firefighters for some reason are apprehensive to put an air pack on at a dumpster fire. SOGs, plenty of SOGs out there. That's a resource that the Fire Smoke Coalition has to be able to get in there and look at other departments, what they have, and we have a lot of departments that have submitted some SOGs as reference for people that want to develop something. Instead of starting with that blank canvas, is being able to have something to start from and fit it into your department's standard format or policy, or look at how you want to get an SOG or an SOP started. This is a good reference in the habitat. And that is basically it. That is the end of my presentation.
All right, Jason. I just wanted to thank you again for this presentation, and also mention that you're going to be teaching at this year's FDIC. And we got a whole bunch of questions here, and I'm wondering if we can't get to all of them, if it's possible, if we could send them to you and you could address them individually, and perhaps we can post the answers on the fire engineering website.
Most definitely.
Okay.
I saw them popping up. I didn't want to get distracted. I tend to have a bit of ADD, so I try not to watch the scroll as it comes across.
No worries. Let's then we'll just start taking some of these.
Sure.
The first one we got is if firefighters know what type of material is burning, is it possible to predict the smoke and vapor components? And I know we got Bobby Sheekin from Ray Systems on here as well, so perhaps he can also jump in if there's anything, any technical questions.
Right. One of the things that we do training symposiums through the coalition,
mm-hmm.
and we go around about once a month, well, two times a month. We're going around different parts of the country, and one of the things that we do in that training program is to actually take small quantities of material and actually burn them. We'll heat them up, and we'll allow them just to off gas, and we'll actually set them on fire and let them burn, and allow students to use meters to kind of look at some of the readings that typical household items may produce. And it's very small quantities, a couple-inch piece of PVC or carpeting, and just allow them to see that. And it's combustion chemistry. It's very complex, and depending on what fuels are involved and the heats that the heat that's there, how far along and how high that fire is getting, the temperature at which those products are breaking down is I don't. I would have to say no. I'm not a scientist, but just by knowing that it's a simple rubbish fire, like a brush fire, basic organic materials are going to give off complex elements. So you're going to have a lot of toxicants coming off of a typical brush fire. So to know what a piece of PVC or laminate flooring or insulation is going to give off would not be able to be done, I don't think.
Okay, and that sort of leads into the next one where we got somebody from Southern California asking if there's been any studies or monitoring done on the respiratory hazards of wildland fires compared to structural fires.
Forestry, the United States Forestry had an issue a couple years ago. I didn't get involved too much in it at all, but heard them looking at something. They had some firefighters get exposed to smoke, and I know they were looking into something, and there was something being done out in Colorado where they were doing some monitoring of gases on the wildland fire setting, but I don't know of anything that's been published or anything that's been done formally.
Okay. We'll go on to the next one. And this asks, we've always been told that 4-gas monitors are not appropriate to use during overhaul because it potentially overwhelms the sensors. So is it appropriate to use 4-gas monitors for CO during overhaul, or should we be using single-gas monitors like CO and HCN?
No, contrary. I definitely have to say that's a myth. Now, we have to look at the setting we're putting into, and I use the analogy of if I wake up in the morning, I look out the window and it's raining. I don't have to turn the TV on to have the weatherman tell me it's raining. I can see that. And I use that same analogy for the fire scene. If I see smoke, then I don't need to monitor because I know gases are present. If smoke is there, you're going to have gases. It's when the smoke goes away and we don't have any visible smoke anymore that we can't really tell if the gases are still there because we can't see those. So that's the time when you need to meter. So I like to monitor on the fire ground outside the building as a safety, not so much to see how high we can get it to go, or let's wait and walk up until the meter goes off and then take a half a step back. Let's position in a safe location where there aren't any gases and my meter's not alarming. So hopefully you shouldn't be exposing it if you are for any period of time outside. Once the fire's out and you've done your ventilation and it looks clear and you're ready to come off air and it looks as if it's a condition, the atmosphere that you'd want to breathe, then you run through with the meter, and typically we find that when we go in, we're getting very, very low readings. But if you're, some departments have looked at having a personal meter assigned, a single gas or an inexpensive meter that they can assign to each person and wear on their gear. I really caution against that because then you're going to leave it on and you're going to take it into the fire, and then you are going to saturate it and you're going to beat it up and expose it to all of that. It is while I have an instance where we've beat up a meter, that was that was an isolated incident. If you do that repetitively, you're going to saturate the meter, you're going to tear it up, and you're going to expose it not just to the heat, but to all the stuff that's going to clog it up and keep it from actually, working later on. And Bobby may be able to offer something on that in addition.
Bobby, you there?
Maybe not.
Oh, perhaps not. Okay.
But to summarize, you can use that 4-gas meter. It's just how you use it. Don't take it in and when it's really smoky and beat it up, because you can't do that with a single gas. There's no difference in it. It's the same sensor. It's just the package it's put into. So whether it's a single gas or a multi-gas, it's still going to beat that sensor up. So.
Hey Jason, it's Bobby Shake. I'm sorry I was on mute earlier. But, just to follow up, I would say. As you said, really, it's a matter of how you use the monitor. I wouldn't really be as concerned. Really, the only sensor that the more likely one to get kind of saturated would be the LEL sensor in a 4-gas monitor. And one thing to keep in mind is that pretty much all 4-gas monitors these days have a built-in shut-off mechanism, so that if you do start to overwhelm that LEL sensor, it will actually shut itself off to prevent damage. And as far as the HCN and CO sensors, like all electrochemical sensors, they certainly have a limited lifetime in terms of how much gas they're exposed to. So, there is a slight chance that, obviously the more gas it sees, you will shorten the life of the sensor potentially. But again, pretty much all 4 gas type meters these days have built-in warranty periods that are not based on the amount of gas it's exposed to, right? So, for example, if it's an HCN sensor that has a 1-year warranty, in the event that you do happen to overexpose it and shorten that life of that, pretty much all manufacturers and certainly Ray Systems will go ahead and replace that under warranty for you. So I would say that the added benefit of having the 4-gas monitor outweighs the potential of overexposing some of those sensors.
All right, Bobby, while we got you on here, we got a question that asks about what advantages the ToxiRay has compared to the multi-ray.
Yeah, in terms of, I guess it really kind of ties into the previous question. They're really, one is a single gas or single sensor monitor, the ToxiRay. We have a few different products. I'm assuming they're referring to the ToxiRay Pro.
Yeah.
And then, the multi-ray is really a multi-gas product, up to 5 sensors, including a photoionization detector. So really depending on the application, in this case, again, I would say, the multi-ray has the added benefit that you can have your traditional, oxygen, flammables, HCN sensor, as well as having a photoionization detector that can be useful as it will basically respond to, a wide range of toxic chemicals. As we discussed, depending on what type of material is burning, it could be a wide range of different types of toxics that can be coming off of that. So that can be a nice added benefit in terms of providing you protection. But really, at the heart of it, I guess, it's really one is more of a personal monitor, a single sensor versus the multi-ray where it's a multi-sensor product that can be used both for personal protection as well as more of a survey type tool.
Okay, I think we'll take one more. We got a lot of these photos coming in now, and again, if your question doesn't get asked, Jason is going to take care of them, and hopefully we'll answer them offline. But I'm going to ask this one: do you find that CO and HCN tend to exacerbate one another? The person who asked the question says they've read cases where HCN and CO have been detected post-structure fire below their individual IDLH, but there have still been fatal exposures.
Yes, from the medical side, there's been a lot of talk about at what levels the lethality of it, and they've had cases where they've had multiple fatal or multiple fatalities within a fire, and looked at a lot of the health risks or the levels and how they related to the cause of the death. And they've had where they were below the quote unquote lethal levels, but yet the people still succumb to the injuries. The two, and that's one of the reasons why we kind of look at CO and HCN, because from the physiological side, the medical side, is that they kind of work as a 1-2 punch to really debilitate the human body. Is one prevents the body from taking in and using the oxygen, while the other one basically prevents or hogs up the oxygen from getting into the body. So even in cases where you can get the body in or the oxygen in and it goes around, the body's cells can't use the oxygen because the cyanide's blocking that ability from the cell to use the oxygen. So those two levels, and it's dangerous because you don't know at what level and what exposure you've had as a firefighter. You could have a 3-year guy get the right combination of gases that takes them down versus somebody that's been doing it for 20 years, or vice versa. So it's tough to say what each individual does, and on top of that, the body has a natural defense that's going to break down those and get rid of those outside gases that aren't typically inside of us. So we're going to have a natural mechanism to get rid of it, but each individual's body is going to do that differently. So one may be better than the other. So you and I may be exposed to the same breakdown of gases, but it's going to affect you differently than it is me, because my body may be better at getting rid of the cyanide or the CO versus yours. So.
Okay, and I guess that's it. I'd just like to tell everybody to please stick around, because we got an exit survey. If you can stick around and take those questions, help us out. And on behalf of Fire Engineering in Penwell, I'd like to thank Jason Cruzen for the presentation, and also our sponsor, Ray Systems, which you can find them at raesystems.com, and they're going to be at FDIC as well at booth 1143. So just like to remind everybody that this webcast is going to be available on demand very shortly, and we'll send you a link to it after we've got the archive up and ready, and you'll be able to find that on fireengineering.com, and we'll send you an email message about the archive as well when it's up there. Thanks for joining us today, and we look forward to future webcasts.